Hey guys, welcome back to the channel. So from the post, selecting the next one. So last time I remember, I think I did this string compression. Let's do this. Oh, seems like it's a hard problem, guys. And the problem is 1163, 1163, and it's named last substring in lexicographical order. Okay, so we are given a string, written the last substring of s in the lexicographical order. Okay, the substrings are A, AB, ABA, ABAB, B, PA, BAB. The lexicographically maximum. Okay. So guys, we have to see all the possible substrings and they should be sorted in the lexicographical order. Like, so you can take A, B as two substrings. Here we have A and B as two substrings, and ABA is one substring and BAB is one substring. We can see ABA, BAB. Also, we can see AB and BA as two substrings, AB and BA here. Finally, AB is and we have to take the last one without, I guess, let's see the constants. The length of string will be between 1 and 10 to the power of 5. So I guess if we have to do it in the time, I mean, without exceeding the time limit. Uh, yes, we have to see the uh, maximum lexicographical order of a substring. It should not start with A, it should start with B, and the length should be maximum. Also here we have to find the uh, max valued string. It is T here, and we have to find the maximum substring from that point. So what are we gonna do? From first in the first step, we are gonna check the maximum first occurring uh, substring. So let's take value equals to 0. So for a range of length of s, let's do one thing. It is way too inconvenient. So enumerate index and if value is less than or d of I, or I guess we can do one thing. Let's take empty string and let's test it out. Print a greater than b and a less than b. And empty string is what if empty string is greater than b? Right. Also, let's see for a. And also we have to check the constraints. So s contains only lowercase letters, so we got no problem. If value is less than I, we have to store the index. Max, no, what do we name it? Max element, maximum element, or we can say maximum value empty, I mean 0 if value is less than I. Maximum max value equals to index. Now what are we gonna do? Turn length of s minus, so the index starts from 0, so we're gonna do -1, and let's see now. Let's print it instead. Let's print length of s 0, 0. How is it becoming 0? Oh, sorry guys, we have to do max value. Sorry. Now let's see. 0, it should be 1, right? So we got 2 instead. And here 4, 0, 1, 2, 3, 4. I guess we don't need to do -1. And let's see. 4 dB. 0, 1, 2, 3, 1, 2, 3. So we add -1. How is it doing? How is it going for the max value? So initially it will come and be 0 and it should be 1. A0 B1. Max value should be 1, but no problem. Initially L and then T. So T is equals to 3. Yes, we don't need to, yeah, we don't need to do it, guys. Right. So let's check again. BAB TCODE. So it's working fine. Let's return it and check. And if it is working fine, then we won't be having any problem. Let's check another case also where so for now seems like it's working, but if it is hard, I don't think this will work. Yeah, you should get CB. How? Okay. I understood, guys. So we got C first, but CA is not lexically greater than CB. So CB is greater. Okay, false. We can do one thing though. What are we gonna do? If value is less than, if value is greater than I, then I, else if val equals to, val equals to I, then what are we gonna do? If value is less than s of index, seems like it's not working. If both are equal and if it's not greater and it is not lesser, what can we do for this is we only have 36 test cases, 13 were fine. Here what are we trying to do is if it is less than the val, then we are changing the index to that position, and We are assigning value that item. I think okay. I think I know what's happening, guys. So value equals to I, but it's not coming here too. If it is greater, or so for c is greater than value, so true. Let's also print value. Okay, guys. Sorry. So initially it's an empty string. Later C becomes C and then CA, CAC, CACA, CACAC. Please ignore it. If both are equal, then it should be at C. So it didn't add a D. Okay. So value does not equals to value. CACACB. Let's do one thing instead, add here and V here. Let's see what happens. Okay. It's false, but the second one is true. Value is greater than Guys, I think I got it. A B is so B is greater than AB. B is greater than B. C A C A C A. So in this case, all are false. So we have to change this for proper. Its value. Damn, it's not going to equals to. So so first condition is true. C is greater. First will always be true. So second one. The second one is true. What is it? C is greater than A, and letter CAC. Wait a minute. CA is CA is not less than C, and CA and C is not is C. Okay. If the max value is less than I, let's deal with it later and see what happening with the remaining stuff. Usually it is false. Okay, see, let's see value later. Let's first check I and so here A, A is not less than I. So we're going to the next one. It becomes true. Max value becomes index value equals to I. Fine. Later A is less than B. So now it becomes B and B is greater than A. So max value, we have to track the max value too. Okay. So max value is 0 here, 0, 1 and 1. Okay, wait a minute. So we have to print the value. A, B, and if value if BA is greater than no, if value is less than we have to do if value is right. So now let's see what's happening here. Triple T code. So L is added, letter T was added. If value is less than okay. See guys, we have to change it here a little bit because so if it is T, what are we going to do? If we find duplicates, then it is causing issue. So let's check it with this. It should give BBAB, but it will give BAB only, I guess. Right. So let's see what's happening with this debugging printing. So initial value is A again, and B. So B is greater than 1, so it becomes B, and it will, since both are equal, it will come here. If B is less than, if B is less than B, and index minus max value. Okay. T. So index minus CA, CBC, CBCA. C, C is greater than index minus maximum. So CA, CBCA, CA, CA, C. So let's C, then C again, and CA later. So if both are equal, we have two steps. If both are equal, we have two steps, either to include the value or to not include the value. I mean, move the max value to the front or leave the max value as it is. So in this case, what's happening is, let's do one thing. Let's try to solve the observable pattern, because here I didn't see, I am unable to see any pattern. So in this case, uh, if we have more than one consecutive greater elements, it is causing an issue. Also, let's see one thing. Actually, let's do this minus a part. Let's see what's happening here. So BA, so B, so index minus maximum value here is 0 because 0 minus 0 0. Now index will be 1 and maximum will be 0. Let's see what's happening in this case. Here index minus maximum is 1. Here the value is 1. Well, I think this will work fine. So let me submit this and check if it is working fine. Then let's discuss the intuition. If it is not, let's try to correct it. I think the comparison will take so much time. Great, it is working fine, but the space complexity, I think we have created new standard here. Uh, so slicing won't be very helpful here. So let's see. It is working fine, and let's see how better approach. So let's see what's happening here. So well, j is less than n. Okay. Well, j is less than n, and s of I1 equals to s of t1. Plus, I'll I'll come in just a minute. Uh, let's stop this here and let's start from where we have left. So I'm back, guys. So let's go where we have left. Hmm. So we have completed it, but it's taking 9027 milliseconds. It's because the comparison might take rough and kind of thing. It might be it is becoming. Let's do one thing. So let's this down to this. So, mm, if L1 is greater than L2. Forgot a comma. Sorry, guys. If it went all the way out, if L1 is maxed out, then we are having a short string here. L1 if either of L1 or L2 is maxed out, let's see. Let's just take case where this is intricate working, guys, because if you are ran out of L1 or L2, max will always be lesser and index will always be greater, because max is uh, assigned after the index, so index will always be greater. So if it maxed out, that means max, because maxwell is behind the index, it will have the longest possible value than index. So most likely L2 will be the one that will be exhausted. We don't need to check. Uh, so L2 will be the one that will be exhausted first. That's for sure. So let me submit it. Also, we don't need to check for L1 case. If L2 exhausts, right? So let me submit it and check. 9027, remember this. 9027 milliseconds. No, let's remove this and add it. Let's see how much time it will take. I didn't expect this much time. So yes, probably that is the reason why it is taking so much time, because we are searching for every other value. Let's do one thing. If LTNS one process, let's try to understand this code. So for j is less than n, okay, initialize it to I1 and J1 while j is less than n. This is what we are doing, guys. If j is less than n and right, if s of I1 is less than s of j1, j equal to I plus 1. If j is less s of if s of L1 is less than s of L2, So instead of going through a while loop, for loop, so if we have same, and if the max value didn't change, then I guess we don't need to check for the next index. No, no. So IDX will be maximum of L1 and L2. Oh shit. It's like it worked fine, but what's happening here? Loss of Maxwell. But nothing changed, right? Let's study this and let's try to implement this, okay? So, so here both of them are initialized side by side, and if the rightmost element is less than length of s, initializing I1 and J1 to I and J, and checking if how many elements are identical. If this while loop didn't is not applicable, it's checking if uh, it exceeds or not, J1 exceeds the length of s or not. If it exceeds, if it exceeds, it will just come to here, which will break the loop and return I, which will be at the starting position. Okay, or else if it does not exceed n and s of I1 is less than s of J1, Okay, if the all same valued elements are excluded, and checking the uh, after excluding part, if it is greater than this, so if it is b and we are checking consecutive s, if b is greater than a, I mean something, if the previous one is less than the next one, then we shall update it to here. So he's taking the maximum of I1 and j. So it will always be, since I1 increases, if I1 does not increase, so taking maximum of I and j, because seems like it is the maximum value and I1 is the starting point. Obviously, no, no, no. So why this kept like, I mean, why is this kept like this? Because we need I to be 1 less than j. So what are we doing? If this loop does not executed, then I1 will be I itself and j will be j itself. So if the previous element is less than the current element, we are updating I to j. Since I1 does not uh, incremented here, I will be less than j, that is 0 is less than 1. So I will become j and j will become I plus 1, the next element. Or else if the previous element is greater, then we should not increment I, rather we have to increment j. So j will be the initial pointer. So let's do the same thing here. Let's start with I comma j equals to 0 comma 1, and if while j is less than length of s, uh, let's keep this clear. We don't keep it I1 and j1. uh, let's keep temp1 and temp2 equals to I and j. So since j is the greater element than I, if temp2 less than length of s and f of temp1 is equal to f of temp2, we are increasing the temporary values. Since we have excluded all the same valued elements which may or may not be included, now we have to check if the temporary if the temporary second value is less than length of the string, and if if, if the rightmost element is greater than the leftmost, we shall increase I to temp1, sorry, temp2 sorry, maximum of temp1 and j, because if temp1 is less than temp2, if the two consecutive elements b is greater than a, then I should be at b. So for a b, if the rightmost value is greater, then we shall keep I at here. So if the temp2 is greater than temp1, we shall keep it in the else condition. If temp2 is greater than, that means if the rightmost element is greater than leftmost element, then what we have to do, we have to keep I equals to then we shall increment j by 1. If the rightmost element is greater, then we shall upgrade I to if two consecutive numbers. If the rightmost value is greater, then we shall keep I here and we have to increment j from there. If not, I will be at this position only. So If the left value is the highest, then we don't need to increment I. I will be as it is. We have to increase j, or else if the rightmost is greater, like this, if the rightmost is greater, then what shall we do? We have to keep I at here. If it increases, I should be at temp 2. Sorry, sir. I should be at temp 1 or j. The maximum of j or temp 2, I mean temp 1. If temp 1 did not increase, then j will be the ideal answer. Else if temp 1 increases, we have to take temp 1 because I is one step behind the j. So, this part is very confusing. Let me check it again. And what is it doing? Is I. If the rightmost value is greater, that's what we did. If the rightmost value is greater, why is it temp 1, maximum of temp 1 and j? We need the point where we have the maximum element, and maximum here is j1. Maximum of. Okay, okay, okay. Wait a minute. Since j1 is greater, shouldn't it take j1 instead of I1? I think this is a bit not very clear. Maximum of 5 on J. And one let's try running and think about the remaining later. On 10 milliseconds. And I'm not really sure how is this working. So it's comparing all the similar values. Since temp2 is the rightmost value, if it exceeds, it is the one that exceeds first. So you are not checking temp1 exceeding the length of string. So here also same, and we are incrementing until we are getting equal values. If the consecutive values, if the rightmost value is greater, then we are leaving I behind and incrementing the j, and temp one. Let's print. So 0, 1. We are going to the next. Let's do one thing. It shall be put with this. Okay. So 0, 1, 2. So it's all else conditions. We are incrementing the j, 3, and we get a different element, et, right? It's by 6. Okay, so now we are incrementing temp1 and temp2 from 3 3, 4, 5. So by 6 we get two different values, and t is greater than c. T is greater than c, right? So t should be at 3 only. So now let's do one thing. Let's remove this z and try doing it again. So by 3, so tempo will become 5 and 6. Maximum of tempo and they will be tempo 1, right? Because it is 5, and temp 2, how did I incremented itself? Wait a minute. So temp 1 will be I, temp 2 will be z. Z equal to temp 2 plus 1. I got it, guys, I got it. So before this, we have to check this also. That's what gonna change our view. So for the first three, it will give 0, 1, 0, 2, and 0, 3. From later on, it will give 3, 4, right? Now here it became 3, 4. So next to this happened. Here T T for ENT, T is greater than E. So we shifted I to T. I to T, which is J in this case, and J to this T. From here, both values are same. So we increase the tempo until we are getting no more. And so 5, 6. So temp is incremented until 6. 0, 1, 2, 3, 4, 5, 6. So we are comparing T and C now, and T is greater than C. So we came to else condition and incremented J. Now let's see. Since u is greater than t, we shift it to u. I is shifted to so tu 0, 1, 2, 3, 4, 5, 6. So t is 5, u is 6. Between and j is 4. So it seems like I was kept here. And in the later step it is incremented to user. So we can directly do one thing. I can be kept temp2 and let's see. So after completing all the comparisons, we are taking the previous element and the next element. Guys, I understood. Let me explain. So what's happening here is, let me make a canvas here. Wait, or shall I let's make a string instead. So a b b b a c d e, sorry, c b a c. So we'll be starting from a and a. Since both are same, the while loop will start and we are gonna shift temp to this place, temp1 to this place and temp2 to this place. Here we are checking if temp1 is greater than temp2 or not. If temp1 is greater, then we are leaving I as it is and incrementing j to the next position. If not, what are we doing? We are keeping I at this position and b at this position. In the next step, it will be checked and incremented to here like this. Temp1 and j. C, B, C. B, if B is less than C, if the leftmost element is less than rightmost element, in the window, if the leftmost element, we are incrementing I to the position. Now let me check the if I is kept at try run it again. Let's try run and think about it again. A and B are same. So temp one like it goes like up to here. Here B is greater than A. So I should be moved here and J should be moved here and start again. But instead, why are we keeping it? Let's do one thing. Let's keep this test case and see the debug log. Let's see. At 0, 1 initially, 1, 2, but T is implemented up to here. So it became 1 and 2. Obviously, this is gonna happen 2 and 3. If we see the every other pattern goes like this only 3 4 and it is shifted to 5. I mean checking 5 6 and we were at 6 7 later. We can simply avoid this tip, right? If I became temp, if I become temp 2, which is obviously if not executed here, the J. So let's see what's happening here. 0 1 CA fine, C fine, So CA, right? Okay. Now J will be incremented. J will be incremented again. Wait a minute. C A. Okay. I will be at 0 only. A. And if both are equal, C A C, then we are going to implement temp1 plus temp2. So now temp1 will be here, temp2 will be here. Guys, I understood, guys. Why is it kept like that? So if temp2 is greater, if temp1 is greater, that means these two were equal. Here C and C are equal, right? So here C and C were taken, and in this case CB is greater than CA. So what's done is we incremented temp plus 1 and temp2 is here, and incremented temp2 to here, avoiding all similarity cases. Since A is less than B, that is the previous element is less than the later element, that is temp2 is greater than temp1, like this, then I will become this C or this C. If the elements are consecutive, then there is no problem. It shall become temp2, but since we are not incrementing anything here, it will recheck the same value after the in the next step, and then things about incrementing J are keeping I equal to temp2. Most obviously the answer will be I will become temp2 in the next step. So let's submit this code. I hope you guys understand the intuition. So what's happening here is we take I at 0 and Z at 1, and we are incrementing I and J by assigning it temporary variables. And if at some position, let me give you the log and give a test case for better understanding. In this test case, let's upgrade it to A and it to A as well. B. In this case, here C, first it will check CA. Since C is greater than A, we increase J. Again C is greater than A. Again C is greater than B. Here C and C are equal. So what are we gonna do? We take temporary variables at Cth position and this C position. Since both are same, we are gonna increment the temp1 to plus 1 and temp2 to plus 1. Temp1 is A, temp2 is A. both are equal. Now temp1 is A, temp2 is B. Since B is greater than A, we are gonna take the maximum one, which is this one, that is temp1. Sorry, yeah, sorry. In this case, the J is the greater one, so it won't take temp1. Or else if we increased C, B, C, A, in this case, if we check again, A and A are same again, B and B are same again. Now C and A, C and C become same, and A become same too. Now J is at this position, and temp1 is at this position. So what are we going to do? We are taking the maximum element, which is temp1, that which exceeds the J. So let's submit this, run this and check if it is getting the right answer or not. See, let's see the log. So we're checking 0, 1, 0, 1, 0, 1, 0, 2, 0, 3, 0, 4. So after 4 it's completed, because it will enter this while loop and it will check these both yes, these both yes, both these, both C's, and C and A, not C and A and A again. Since it is not greater than this, we're just gonna increment J. Sorry, temp2 is not greater than temp1, so we are gonna increment J, and J exceeds the length of array, so we are returning as of I. If it is D instead, then we will have another step extra. In this case, we are checking C, C, A, A, B, B, C, C, A, D, D is greater than A, so we incremented I to max of temp1 and J. J is here, so temp1 is here, Increment temp1 to here, and j becomes a again. So both are same. So we're going to increment j. Now checking a and b, we are shifted to b. Checking b and c, we will be shifting to c. Checking c and d again, and we will be shifting to d. So there are few redundant steps involved, but it is work. It will work in majority cases with a very little compromise. So it can be taken, I guess. So hope you guys understood the intuition and enjoyed the uh, process. Keep pushing hard, keep learning, and all the best, guys. Goodbye. Take care.